Hi and welcome to 2015 question B2. So the 3D graphic below shows an exterior light, which we can see here. On the cap of the light, right up at the top, is a regular hexagonal prism, and it's penetrating a square-based pyramid. Okay, so two shapes that we'd be well used to dealing with. In figure B2, it shows the incomplete isometric projection using axonometric axis method of two solids which penetrate each other. The plan and incomplete elevation are shown in their required positions. Pictorial view of the intersecting solid is also shown. So here's our pictorial view. We have our incomplete elevation, our plan, and our incomplete auxiliary. So part A, draw the axonometric axis x, y, and z and the equilateral triangle ABC, which is a side 110 millimeters. So set up our question, almost the same, well, same method all the time. So let's get cracking with that. So it's axonometric axes. We've got our x, y, and z all 120 degrees apart. So right around the middle of the page here, I'm just going to go vertically. Back at an angle, 30 degrees and 30 degrees. Okay. And they're saying that the triangle is going to be 110, so I'm just going to extend this line down and measure 110, so that's going to be 55 on either side. So that's the base of our triangle, okay, and the side of the triangle will always be at 90 degrees to the axis, so if that's at 30, we're going to be going 60 degrees here, and 60 degrees here. Okay, I'm now going to project down for my plan view. Okay, so position our plan view there. Okay, we need to draw a semicircle, so to find the center of that semicircle, I just need to extend down my axis a little bit further. Semicircle will be radius 25 or 55, which we don't need to measure, it's set up for us already. And then join back from there to there. So locate our vertical planes, our edge view of our vertical planes. Okay, so that's set up, and I'm gonna draw. Sorry, part A already completed. Equilateral triangle sides. Yeah, so that part there on its own is part A completed. Okay, so onto the plan view and the incomplete elevation. So just going to draw the orientations first of all. So out here, 30 degrees also. Okay, and should be far enough. Project out my axis there to find the center, so I can draw my circle or semicircle in. Okay, and I'll draw edge view of my vertical axis or vertical plane, edge view of my horizontal plane. Okay, so now we can draw our plan view. So they haven't given us, or they have given us the length of the base of the pyramid. So that's our square base for our pyramid. Okay, we also need to draw in the edges of the sides, the triangular sides there, but we don't know where those are going to finish just yet, so I'm actually going to draw my hexagon. Okay, the side is length 30 and they tell us it's out to 15, so I'll actually draw that circular profile. You can see there's a circular profile on that, which is going to be 35 plus 15, so 45. So let's just draw a line through the centre. It's going to be 30 in the centre, so that's split 15 in half. 30 and 15, so 30 out. Okay, so set the profile, and it's telling us that it's length 30, so that's 50 either side. I can draw a line down onto my circle, and that will find the position of 2 corners. Okay, I have another corner existing, have another corner existing, and then I can actually project all the way through for those 2 30s, or those 2 15 marks. So let's measure my 30 marks there. Okay, so I have one side, second side, and I can draw the last couple of sides, then just drawing up the points that I've already found. So not too bad a setup in this question. Basic kind of geometry. And finally we just need to draw in the sides of our pyramid, where the edges there leading to the vertex. Okay, so plan view completed there. Now we want to draw our elevation. So the side there, let's put that on the table so you can see it. So our square base pyramid, the height of it is in line with that point there. So I'm actually going to use side instead of squares just to project across that height. Okay, the length, one side, no, we don't have length on one side. Okay, so I'm going to use corresponding width, so looking at my elevation here, okay, is looking from this side. So I can take measurements to the center there to find the apex of that pyramid. So that's the center of the pyramid, and I can draw that up. Okay, and now I want to draw the profile here of the rest of it. So we've got 30, which is 15 either side of the apex, and then the outside edges, which are 15 further from that. Okay, and use sliding set squares then to draw the outline. Okay, I don't know where that finishes. That finishes the outside profiles. I know, or edges. I know, go down onto there. Okay, so we've got draw the plan and incomplete elevation in the orientation as shown, so that is now completed. Finally, they want us to complete the drawing showing all lines of interpenetration on the axial or on the axonometric projection and in the elevation. Okay, so can we find those points just yet? No, we're going to use the axonometric projection. So first off, I'm going to draw the projection of the square base pyramid. Some of those points are already projected up, so I just need to project them back. The apex. And that is also projected back here. Okay, so I've got my base. So I've already joined up, and here is the other side. Okay, so just make out the outline there of my square base pyramid. Okay, I'm going to project up the top profile there of the hexagonal prism, just kind of while we're to kind of make things a little bit more concrete and easier to kind of follow once we have the outline of that profile too. Okay. So at this point now, we want to start finding some points of interpenetration between those two solids. So the method that I'm going to use, actually we got the limits method. So here's a limit where where the edge view of that surface of the pyramid intersects here. So I can actually use the limits method for that and project back onto the corresponding edge. So that has found one edge. Okay, and the corresponding edge on the far side, we're actually not going to see it, just to know it's there. Okay, so we're not going to see that. Okay, and so limits, that's the only limits that I can use. So next we're on to using straight line elements. Okay, so I'm going to use straight line elements across here. So I'm going to draw essentially a straight line element that contains this line. Okay, and we'll find a reference on that edge of my pyramid and this edge of my pyramid, which I can then draw in elevation and then actually project up and find the same element, straight line element in elevation, at the end elevation. So there we have it. I project that up onto this edge. I'm not going to find it there, but here we have parallel lines, appear parallel. So I'm going to have artillery line. This is being projected up. So there we have that straight line element again, which contains those. So I can find that surface. Okay, and I'm going to project that back, show that edge in heavy. Now that I have it, I'm actually going to project back those points then. Actually, you know, I'll project back the straight line element. It'll just be kind of a little bit clearer. So, parallel lines, parallel all views. Surface also in my elevation. Okay, now we're trying to find the turning points of that point and that point. Yes. Okay, so to find those turning points, I'm actually going to draw another straight line element that contains that point. Because I have that, yeah, that will work. So straight line element here containing that point. So this, just to be clear, is a line here. That's what I'm creating. Okay, that contains that turning point that I'm looking for. Okay, and so let's draw that. So that's touching the base. Okay. So it's touching the base of the cone. And it's also running through that point which I've already found up here. So let's drawing. Let's check that now. That all makes sense. So let's project. Straight line element that contains that edge now. Okay, which will allow me to actually draw this edge of my pyramid, this edge there. Okay. Now, I'm not going to be able to find that straight line element here because it will just appear on that surface. So I can actually use my limits now to go back onto that edge. Okay, which will actually find it on this surface also, won't it? Yeah. So we've now projected that back, so I'll find it in that point as well. So it's there. Join that to there. Great. And now let's draw those all in our elevation. Okay. And its corresponding points, because it's all pretty symmetrical. So project that across. So now we found that elevation. Okay, I think that's the outline of our elevation completed. And just to finish it off here, we need to finish off the back edge of that pyramid and the back edge of the hexagonal prism. Okay, and just to double check we've got everything included. Right, they're saying it's not necessary to include hidden detail, so we don't need hidden detail. Just to check for reference, everything the same between these two views, the one that's given to us. Yeah, so that's our 2015 question B2 completed there. Nice question linking axonometric projection and intersecting solids.